Hi everyone, welcome back to Info 3370, studying social inequality with data science. Today we're talking about asking research questions. This is an important topic as you are all beginning to ask your own research questions for the final project of the class. Our goals today are to articulate a clear research question and to use language appropriate for causal or descriptive research questions. We started out our discussion in class with a general conversation about what makes for a good research question. In small groups, we talked about what makes a question good, and there were some really nice ideas. Those ideas included that the question ought to be feasible, where you could actually go get the data that you need to answer that question. The question should be simple enough that you can answer it with a few variables and thus finish the analysis. It should also be simple enough that you can explain it to a reader who might not know much about your area and convince them that that's a kind of question that matters. These are all important things to consider when choosing your own research question because you want to get it done and you want to produce a result that's important and means something to others to whom you might present that result. I have some specific thoughts about what makes for a good research question, so I'm allowing myself to digress briefly to talk a little bit about this paper, What is Your Estimand? Defining the Target Quantity Connects Statistical Evidence to Theory. This is a paper that I published with Rebecca Johnson and Brandon Stewart in the American Sociological Review, and we have some particular suggestions for how to think about using statistical analysis to estimate quantities that speak to meaningful theoretical questions. In particular, we argue that there are two keys to a good research question, or more specifically, two keys to a specific quantity that you plan to estimate in a statistical analysis. The first consideration here is that there be a unit-specific quantity. This is something defined for each person. It could be factual or counterfactual. So if we want to know what proportion of people are employed, then our unit-specific quantity is employment. For every person, we have a definition, employed or not. It could also be counterfactual, where for each person, we would say, would they be employed if they received a job training intervention? Having defined the unit-specific quantity, we then can define a target population, some set of units about whom we wish to infer. I think it's really helpful when defining a research question to specify the target population very precisely. So we might say we want to know about the proportion employed among people ages 20 to 35 who finished a college degree, for example. There are many ways to specify a unit-specific quantity and a target population. There's no specific correct answer. It's really a conceptual choice about what you think is a meaningful quantity to be estimated in your statistical analysis. So one version of this question would be to describe a population. So like I just said, what's the proportion employed among here U.S. resident women ages 21 to 35? In this case, we have a well-defined target population, it's a set of women, and we have a unit-specific quantity, employed or not. We could also describe population subgroups. We might say, what is the proportion employed among U.S. resident women ages 21 to 35, comparing mothers to non-mothers? Here we have the same unit-specific quantity, employment or not, and we have two target populations, a set of mothers and a set of non-mothers, in this case including all those who are U.S. residents ages 21 to 35. Finally, we could also consider a causal effect in a population. What is the causal effect of motherhood on employment among U.S. resident women ages 21 to 35? So here I have a population of women, and I have a potential outcome, whether each woman would be employed if she were a mother, and whether each woman would be employed in a counterfactual world where she's not a mother. For each woman, either Y1 or Y0 is counterfactual, and the other one is the factual observed outcome. The causal effect here is the unit-specific quantity of interest. This is the difference in her outcome in a world where she's a mother and a world where she's not a mother. The reason I've gone through these examples is that these are two very different research goals. In the top example, we're comparing the employment rate among one set of women who are actually mothers and another completely different set of women who are actually not mothers. In the bottom, we're comparing the employment rate for the same set of women under two counterfactual conditions, one where they're mothers and one where they're not mothers. If your research goal is the population subgroups at the top, then you can't say anything about why women have different pay. You can just say something about the mean pay among this group and the mean pay among another group. But if you wanted to say something like motherhood causes women to have lower pay, then you would really need the claim at the bottom. And if that bottom claim is the one you're after, then you really need to include a directed acyclic graph or another form of causal assumptions to help support that claim. So when you think about asking research questions, I think a really fundamental thing to consider is whether the question being asked is a descriptive research question or a causal research question. And when answering this question, you can often think about a few keywords that appear in the research question. So for descriptive questions, we often use words like among, across, difference, or for those who. So we'd say, what's the average pay among mothers? What's the average pay among non-mothers? Really clear there that we have two sets of people. For a causal research question, we often use a different set of words. We would ask, for instance, whether motherhood causes pay, or affects pay, or produces pay, or impacts pay. In these cases, we're really asking a question about various counterfactual conditions where we're imagining that that key treatment variable takes various different values for a given person. Between descriptive and causal claims is a region that I'm calling the murky middle. These are words where it's not entirely clear if the researcher is after a descriptive claim or a causal claim. Now, to be transparent, I have written papers that talk about things leading to or predicting other outcomes. I think these words can be used effectively where one is, in other places in the paper, clear about whether one means them in a descriptive sense or a causal sense. But when you're not super clear about it, you can see how you can lie in a middle ground. Like motherhood is associated with pay net of education, age, and work experience. That starts to sound like what you're really after is a causal claim, couched in descriptive language. For our purposes, when possible, I think it's best to avoid the murky middle and try to focus on explicitly descriptive questions or explicitly causal questions. When you look across these types of keywords, you'll notice a trend. So if you look at the causal words, you see that they are all verbs. Causes, affects, produces, impacts. When we ask about a causal question, the treatment is actually doing something. We have like treatment, verb, outcome. For descriptive questions, the relevant keywords are not verbs. We would say that there's an outcome among one group and among another group. So to put this on the slides, statements that take the form predictor, verb, outcome, motherhood causes pay. Those are often causal and they often need a DAG. Statements among subpopulation 1, there's a mean outcome. Among subpopulation 2, there's another mean outcome. Those tend to be descriptive statements, and in those cases you wouldn't need a DAG. You'd also be constrained in your conclusions to not draw any causal conclusions at the end of the study. So those are our learning goals for today, are to think a bit about what makes for a good research question and to articulate a clear research question. I find it very helpful to think about the unit-specific quantity for each person in the population and the target population, the set of people about whom one wants to infer. Not everyone finds that helpful. It's just one way of thinking about what makes for a good research question. I think it's also helpful to use language appropriate for your causal or your descriptive questions. There are really important descriptive questions out there, and for those questions, it's helpful to ask it in a framework that makes it clear that what you're after is a description. What's the incarceration rate among black men and among non-black men? For other questions, the research goal is causal. And in that case, I don't think we should shy away from the causal language. If we want to know whether college affects socioeconomic opportunities, we should use that word affects and draw a DAG to support our conclusions. So those are my 2 cents about what makes for a good research question, and I'm really looking forward to the research that you all will be producing in this class for the final project.